Alright, so I am going to go through your guys' study guide for the exponent, scientific notation, squares, and square root test that you guys will have on Monday for cohort 1 or Tuesday for cohort 2. So these first 8 questions are just the basic exponent rules that you guys needed to know. You guys took a quiz on this last week or this week. So let's just review. So remember that when you have the same base with exponents and you're multiplying, you're going to keep the base the same. So in this case, v is going to stay v as our base, and then you'll just add your exponents. So 3 plus 6 gives you 9, so your answer is v to the 9th. When you are dividing with exponents, your base again will stay the same. So notice that our base is 6, so we will keep our base of 6. And then you will subtract your exponent, so 8 minus 2 gives you 6 as well. So your answer will be 6 to the 6th power. So the main thing is remembering that when you're multiplying, you're going to add your exponents, and when you're dividing, you are going to subtract your exponents. Number 3, notice that we do have coefficients. So when you have coefficients, those are numbers attached to variables. So that means that you can multiply or divide like normal. So in this case, we will multiply the 4 times the 5 to give you the 20. And then your bases, you will keep your base as u. And then since you're multiplying with exponents, you're just going to add your exponents. So 3 plus 12 is 15. So your answer is 20u to the 15th power. Number 4, remember anything to the 0 power is just equal to 1. So in this case, a to the 0 is equal to 1. And then you're still left with a b to the 15th. So you could leave this as your answer, or since a to the 0 is just 1, it technically cancels out since anything times 1 is just whatever you have left. So in this case, number 4 should just be b to the 15th. Number 5, remember when you have power to a power, this is when you are going to multiply your exponents. And please don't forget that whole numbers do have an imaginary exponent up top. So in this case, that 5 is actually 5 to the 1st power, so that then when I go to multiply my 5, I'm multiplying it times all of my exponents on the inside. So in this case, this 5 to the 1st power, if I take it to the power of 5, this will now be 5 to the 5th power. And then c to the 3rd power now changes into c to the 15th power if you multiply them. So multiplying exponents, you add them. Dividing exponents, you subtract them. A power to a power is when you will multiply them. Alright, so notice for number 6 that you can't simplify anything since you don't have the same bases. But notice how this p to the negative 2, he's not happy where he's at, so we need to make him a positive exponent. So since he's not happy downstairs, you will move him upstairs to where now he's happy with everybody else. So your final answer will be 12n to the 2nd, and then p to the 2nd, since he will now become happy. Alright, number 7, we can simplify these. So these are multiplying because a parentheses shoved up next to another parentheses means that you're multiplying. Please don't forget that this a has an imaginary 1 up as its exponent. So when you are multiplying, you keep your same base of a, and then you add your exponents together. So 8 plus 1 gives you 9. You'll do the same thing with the b's, but in this case, this is b to the 0 power. So remember in number 4, anything to the 0 power is equal to 1. Or in other words, when you're multiplying, it just cancels out. So the only thing that we have left would be this b to the 2nd power. So your answer should be a to the 9th, b to the 2nd. And then your last question here, notice how you can't simplify anything in the parentheses, but you do have a power on the outside. So when you have powers to powers, that's when you'll multiply. So in this case, r is your base, and r is going to stay the base. You'll take 7 times 2, which gives you 14. And then you'll do the same at the bottom. So u will stay your base, and you'll take 6 times the 2, which will give you 12. So it should be r to the 14th over u to the 12th. So here's the answers. Again, you guys can pause the video at any time, but I'm just going to go ahead and keep moving on here. So number 9, in 2013, the Los Angeles Dodgers opening day payroll was about $2.16 times 10 to the 8th power, and the Houston Astros opening day payroll was about $2.40 times 10 to the 7th power. How much higher was the Dodgers payroll? So this is scientific notation. Remember, with scientific notation, if you are adding or subtracting, you need to have the same base to the same power. If you're multiplying or dividing, you don't have to have same base to the same power. Okay, so in this case, if we're trying to figure out how much higher was the Dodgers payroll compared to the Astros payroll, we actually need to subtract these numbers. So we have 2.16 times 10 to the 8th, and all that will be subtracted by 2.4 times 10 to the 7th. So remember, when subtracting with scientific notation, you need to have your 10 base. It needs to be to the same power. So a couple different ways you can do this. We can change this 10 to the 8th to a 10 to the 7th, or we can change this 10 to the 7th to a 10 to an 8. Either way, you should still end up with the same answer. What we have been teaching, though, is we always want you guys to change the smaller number, so the smaller exponent, to the larger one. So let's just go ahead and do that. So if I want my exponents to be the same, I'm going to change this 10 to the 7th to where now it's going to be 10 to the 8th power. And when we do that, notice how all that we did was we added 7 plus 1, which gave us 8. So in other words, this is multiplying another 10 to get us to 10 to the 8th power. But when we do that, we also have to change our number over here, because if you're multiplying times 10, we need to even out this number to where if we said 10 or 2.4 times 10 to the 7th is still equal to whatever we have down here, because we don't want to change up what the number is, okay? So the rule is, if you're adding 1, so in other words, multiplying times a positive 10 to get you this 10 to the 8th, since you're making this bigger, you need to make this number smaller. So to make it smaller, you want to move your decimal point to the left. And since we only added 1 extra number to get it to that 10 to the 8th, you only need to move your decimal point 1 number to the left. Okay? You don't want to move it to the right, because if you move it to the right, you're making 2.4 into 24, which is a bigger number. And we also made this number bigger, so our number won't be the same anymore. So that's why we want to move it 1 unit to the left, so that now the 2.4 times 10 to the 7th is the same exact number as 0.24 times 10 to the 8th. And then this works in our favor because we now have same base to the same power, so we can subtract this scientific notation like normal. So take your numbers that you have and subtract them like normal. And yes, you may use a calculator, but subtracting decimals is pretty easy, so I'm just going to do it by hand real fast. So that equals 2, that equals 9, and I'm left with 1.92. And then, since we have the same base to the same power, when you're adding and subtracting, you want to keep it the same. And notice how this number is between 1 and 10. So I know that I am done. So the Los Angeles Dodgers get paid on their payroll $1.92 times 10 to the 8 more. Alright, so let's look at number 10 here. So a TV show had 3.5 times 10 to the 6 viewers for their first episode and 8.5 times 10 to the 6 viewers for their second episode. How many viewers did they have overall? So in this case, we will be adding, since they're wanting to figure out how many viewers overall do they have. So we will be adding these two scientific notations. So go ahead and write down 3.5 times 10 to the 6, and we will be adding that to 8.5 times 10 to the 6. So remember, when adding and subtracting with scientific notation, you need same base to the same power. So we need to double check to make sure we have that, which in this case we do. So we don't have to change anything. We can just go ahead and add like normal since we have same base to the same power. So looking at our numbers here, we have 8.5 plus 3.5. So 8.5 plus 3.5 gives us 12, and even 12 here. And since we have the same base to the same power, we will keep that the same. And then this will be my answer. However, notice how this number is not between 1 and 10. So I need to move this decimal point to where it will be between 1 and 10. To make it into scientific notation. So I need to move this decimal point 1 unit to the left so that now it's 1.2. And when I moved it 1 unit to the left, I made the number smaller. So since I made it smaller, I need to make sure that I account for that over here by adding 1 to my exponent. So I need to multiply this 10 to the 6 times another 10 to the first power to account for making this unit, or making this number smaller by dividing it by 10, in other words. So since I made it smaller, I need to add 1 to my exponent here. So this will now be 1.2 times 10 to the 7th. And that is my final answer. Alright, number 11, how many times larger is 13,500 compared to 1.5 times 10 to the 3rd? Write your answer in standard form. So for this answer, or this question, notice how we need to change this 13,500 into scientific notation form so that we can solve it. And since we're trying to figure out how much larger that number is, we actually need to divide. So if I were to take 13,500 and divide that by 1.5 times 10 to the 3rd, I need to change this to scientific notation. So if you remember, this number is greater than 1, so there is a decimal point at the very end here. And if I want to change it to scientific notation, remember it has to be a number between 1 and 10. So I need to move this decimal point all the way over. So 1, 2, 3, 4 units over until now I have a number that's between 1 and 10. So when I moved it 4 units to the left, I now have 1.35. And you can attach those zeros if you want to, but you don't have to. And then, since you moved it 4 units to the left, remember that you made the number smaller. So since you are making the number smaller, you need to account for that by your base of 10 here needs to be the positive exponent to account for all the numbers that you made 13,500 smaller. So since you moved it 4 units to the left, you should have 10 to the positive 4 power to account for making your number smaller here. So that then, if we were to multiply this out, 1.35 times 10 to the 4th is the same thing as 13,500. Okay? And then you're just going to divide like normal to get your answer. So I am running out of time here. I'm only allowed 15 minutes for this app that I'm using, so you should be able to move on to part 2 of this video, and part 2 of this video I will finish this up.